This is SpaceTime Series 28, Episode 20, for broadcast on the 14th of February 2025. Coming up on SpaceTime, new discoveries challenge long-held theories about Earth's missing elements, trench-like features on Uranus's moon Ariel may be a window into its interior, and the Comet Atlas destined to die. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has revealed a surprising twist in the story of Earth's formation 4.6 billion years ago. Understanding where Earth's essential elements came from and why some are missing has long puzzled scientists. Now, a report in the journal Science Advances challenges traditional theories about why the Earth and Mars are depleted in moderately volatile elements. These elements, like copper and zinc, play a crucial role in planetary chemistry, often accompanying life-essential elements such as water, carbon and nitrogen. Understanding their origin provides vital clues about why the Earth became a habitable world. The problem is, Earth and Mars contain significantly fewer moderately volatile elements than primitive meteorites known as chondrites, and that's raising fundamental questions about planetary formation. This new research takes a fresh approach by analysing iron meteorites, remnants of the metallic cores of the earliest planetary building blocks, in order to uncover new insights. The study's lead author Daman V. Gruval from Arizona State University says the team found conclusive evidence that first-generation planetesimals in the inner solar system were unexpectedly rich in these elements. The discovery reshaped science's understanding of how planets acquired their ingredients. See, until now, scientists believe that moderately volatile elements were lost either because they never fully condensed in the early solar system or because they escaped during planetesimal differentiation. However, this study is revealing a different story. It seems many of the first planetesimals held onto their moderately volatile elements, suggesting that the building blocks of Earth and Mars must have lost theirs later, during a period of violent cosmic collisions which shaped their formation. Surprisingly, the authors found that many inner solar system planetesimals retain chondrite-like moderately volatile element abundances, showing they created and preserved them despite undergoing differentiation. This suggests that the progenitors of Earth and Mars did not start out depleted in these elements, but instead their loss occurred over a prolonged period of collisional growth rather than through incomplete condensation in the solar nebula or through planetary differentiation. This work redefines how science understands the chemical evolution of planets. It shows that the building blocks of the Earth and Mars were originally rich in these life-essential elements, but intense collisions during planetary growth caused their depletion. This is SpaceTime. Still to come, trench-like features on Uranus's moon Ariel may be a window into its interior. And as we predicted last month, Comet G3 Atlas is dying after it swooped too close to the Sun, causing its nucleus to break apart. All that and more still to come on SpaceTime. A new study has raised the possibility that a giant trench-like feature on Uranus's moon Ariel could be a window into its interior. Last year, a study led by planetary scientist Richard Cartwright from the Johns Hopkins Applied Physics Laboratory in Laurel, Maryland, proposed that deposits of carbon dioxide ice and other carbon-bearing molecules on Ariel likely originated from chemical processes inside the moon, possibly even from a subsurface ocean. Now, new research may shed light on how these minerals reached or even are still reaching the moon's surface. The new study, led by Chloe Bedingfield, also from Johns Hopkins, points to medial grooves, trenches that cut through Ariel's massive canyons, as likely conduits for this exchange. The findings, reported in the Planetary Science Journal, suggest that these grooves are spreading centres, like mid-ocean ridges creating new crust on Earth's seafloors by bringing up internal material that forms a new surface. Bedingfield says if correct, these medial grooves are probably the best candidates for sourcing those carbon dioxide deposits and uncovering more details about the moon's interior. Among Ariel's youngest known surface features, the grooves have long been suspected to be products of a complex interplay between tectonic and volcanic activities. Using images taken by NASA's Voyager 2 spacecraft, the only mission to pass by Uranus and its moons, the authors considered that the grooves may have formed through fissures or volcanic conduits. But the new analysis leads strongly towards spreading centres. For example, the canyon walls flanking the grooves fit together like puzzle pieces when their central floors are digitally removed. And the canyon floors display regularly spaced ridges in some locations, akin to the tracks of a construction excavator, consistent with a series of material depositions. Spreading centres arise from convection cells beneath the crust. And heat from Ariel's interior would cause material to ascend, splitting the surface and forcing it apart as the material is emplaced and gradually cools. Curiously, Ariel and several other of Uranus's moons experienced multiple periods of geological activity driven by tidal forces. These forces, stemming from period resonances, that is where each of the moon's orbital periods align in precise ratios, causes their icy interiors to cycle between phases of heating and in some instances even melting and then freezing again. Scientists think these resonances are helping to sustain oceans beneath Ariel and also its smaller neighbour Miranda. For instance, in 2024, a study proposed that such resonances formed an ocean within Miranda's interior, and that this ocean might still exist there today. When it comes to Ariel's possible ocean, the authors highlighted the importance of the medial grooves for understanding the likely short lifespan of carbon oxides. It suggests a possible mechanism for emplacing fresh material and short-lived compounds, including carbon monoxide and perhaps ammonia-bearing species on the surface. Ariel, too, may host a thin remnant ocean, although Bedingfield remains cautious about drawing direct links between that ocean and the medial grooves. The size of Ariel's possible ocean and its depth beneath the surface can only be estimated, but it may be too isolated to interact with any spreading centres. And while carbon dioxide ices are present on Ariel's surface, it's still unclear as to whether they are associated with the grooves. That's because Voyager 2 didn't have the instruments on board to allow it to map the distribution of the ices. To find the answers, Cartwright's emphasised the need for further exploration and the importance of a new dedicated Uranus mission. He says scientists need an orbiter that can make close passes of Ariel, map its medial grooves in detail, and then analyse their spectral signatures for components like carbon dioxide and carbon monoxide. If carbon-bearing molecules are concentrated near these grooves, then that would strongly support the idea that they are windows into Ariel's interior. With Uranus now climbing in the ranks of exploration priorities, Ariel and its enigmatic medial grooves may soon come under closer scrutiny, offering scientists an unprecedented look into the moon's past, possibly even its presence. This is SpaceTime. Still to come. As we predicted last month, Comet G3 Atlas is dying after it swooped too close to the Sun, causing its nucleus to break apart. And the constellation of Orion the Hunter, the red supergiant Betelgeuse getting ready to go supernova, the Pleiades open star cluster, and the spectacular Magellanic Clouds are among the highlights of the February night skies on Skywatch. Well, as we predicted last month, Comet G3 Atlas is dying after it swooped too close to the Sun, causing its nucleus to break apart. Atlas passed well inside the orbit of Mercury as it reached perihelion, its closest orbital position to the Sun. It's a location where the Sun heats and destroys many comets. Now, as it moves away from the Sun, the comet's becoming dimmer and dimmer, a sort of headless wonder flying through space. It's currently lighting up the southern hemisphere skies, with impressive tails near the horizon just after sunset. Images taken in mid-January show the comet's ice and rocky nucleus still looking bright and centrally condensed. But over successive nights across late January, the nucleus became more diffuse as it fragmented and began to disintegrate. Some of the comet's scattering remains of rocks and ice will continue to orbit the Sun, some in nearly the same outward section of the orbit that the comet's nucleus would have taken. Atlas has been an impressive sight, so bright and awe-inspiring that it may eventually become known as the Great Comet of 2025. This is SpaceTime. And time now to turn our eyes to the skies and check out the celestial sphere for February on Skywatch. February is the second month of the year in the Julian and Gregorian calendars. It's also the shortest month of the year and the only one which is a length less than 30 days. The month is 28 days in common years and 29 in leap years, with a quadrennial 29th day being called a leap day. This additional day every fourth year is needed to keep the calendar year synchronized with the astronomical year. Because seasons and astronomical events don't repeat in whole numbers of days, calendars that have the same number of days in each year tend to drift over time with respect to the event the year is supposed to track. By inserting an additional day every fourth year, this drift can be corrected. The extra days occur in years which are multiples of 4, with the exception of years divisible by 100, but not by 400. Similarly, in the lunisolar Hebrew calendar Adar Aleph, a 13th month is added 7 times every 19 years to the 12 lunar months in its common years, in order to keep its calendar from also drifting through the seasons. And in the Baha'i calendar, a leap day is added whenever it's needed in order to ensure that the following year begins on the vernal equinox. The length of a day is also occasionally changed by the insertion of leap seconds into Coordinated Universal Time or UTC, more often referred to as GMT or Greenwich Mean Time. This is needed because of the variability in Earth's rotational period. But unlike leap days, leap seconds aren't introduced on a regular schedule, since the variability in the length of the day is not entirely predictable. Okay, let's turn our attention to the sky now. And throughout most of February, sky watchers in the southern hemisphere may be lucky enough to catch sight of the occasional meteor associated with the Alpha and Beta Centaurids meteor showers. Now, as their names suggest, they appear to radiate out from the direction of the constellation Centaurus as 2 separate streams, although they rarely produce more than 1 or 2 meteors per hour. They usually peak around February the 8th, and to see them at their best, you really should be looking towards the east a few hours before dawn. Okay, looking north now and high in the sky is the famous constellation of Orion the Hunter. Orion is one of the best known and most recognized constellations in the sky. In Greek mythology, Orion was the son of a Gorgon and Poseidon, who was also known as Neptune, the god of the sea in Roman mythology. Orion was a mighty but egotistical and conceited hunter, who once boasted that his skill would allow him to kill all the world's animals. So the earth goddess Gaia sent Scorpius the scorpion to kill him and save the animals. Orion was stung in the shoulder, but then the healer Ophiuchus intervened to save him and crush the scorpion. Both Orion and the scorpion were then placed in the heavens to play out the story each year, with Scorpius rising in the east as the defeated Orion sets in the west. Now, a variation of this fable speaks of Orion getting a little bit too close to Artemis, the goddess of chastity. Now, her brother Apollo didn't approve of this relationship and tricked Artemis into testing her skill by shooting an arrow at a distant speck on the ocean. What Artemis didn't know was that that speck was actually Orion, swimming to escape the giant scorpion created to kill him. When Artemis discovered what she had done, she placed Orion's body in the sky as the stars we see today. Similar variations to this story appear in other cultures, including ancient Egypt, where Orion is known as Osiris, the god of the underworld and of regeneration. The very earliest depiction that's been linked to the constellation Orion is a prehistoric mammoth ivory carving found in a cave in the Arch Valley in West Germany in 1979. Archaeologists have estimated that it would have been fashioned somewhere between 32,000 and 38,000 years ago. The distinctive pattern of Orion has been recognized in numerous cultures around the world, including ancient Babylonian star catalogues dating back to the Late Bronze Age. Orion's easily identified by its rectangle of 4 stars, surrounding a central trio of stars in a row which form Orion's belt. And hanging from the belt are the stars which make up the Sword of Orion. To those of our listeners in the southern hemisphere, Orion appears to be upside down, with the sword on his belt pointing upwards. And if you look really carefully, you'll notice that the middle star in the sword looks a bit fuzzy. That's because it's not a star, but rather a huge star-forming region known as Messier 42 or M42, the Great Nebula in Orion. Located some 1,344 light-years away, M42 is the nearest large star-forming region to Earth, containing hundreds of newly forming stars and protostars. A light year is about 10 trillion kilometres, the distance a photon can travel in a year at 300,000 kilometres per second, the speed of light in a vacuum, and the ultimate speed limit of the universe. The Orion Nebula is more than 24 light years across, and it contains as much mass as 2,000 suns. It's one of the most scrutinised and photographed objects in the night sky, and is among the most intensely studied celestial features. The Orion Nebula has revealed much about the process of how stars and planetary systems are formed from collapsing molecular gas and dust clouds. By studying M42, astronomers have directly observed protoplanetary disks, brown dwarfs, intense and turbulent motions of gas, and the photoionizing effects of nearby massive stars in the nebula. The Orion Nebula contains a very young open cluster known as trapezium due to the asterism of its 4 primary stars. The trapezium itself is a component of the much larger Orion Nebula cluster, an association of around 2,800 stars within a diameter of just 20 light years. The brightest star in the constellation of Orion is the semi-regular variable red supergiant Betelgeuse, which represents the scorpion's sting on Orion's shoulder. Currently known as Betelgeuse, and commonly referred to by the public as Betelgeuse, don't say it 3 times, the names are both tortured mispronunciations of the original Arabic name Ibtal Yauza, meaning the hand of the big man being Orion the Hunter. Located some 643 light years away, Betelgeuse is the 9th brightest star in the night sky. And it's big, really big. In fact, red giants like Betelgeuse are among the largest stars in the universe, at least in terms of volume, although they're by no means the most massive or luminous. Calculations of Betelgeuse's mass range from slightly under 10 to a little over 20 times that of the Sun, and it shines with some 100,000 times the Sun's brightness. If it were placed at the location of our Sun at the centre of our solar system, its visible surface would extend almost as far out as Jupiter, engulfing the orbits of the planets Mercury, Venus, Earth and Mars, as well as the main asteroid belt. Betelgeuse began its life around 10 million years ago as a spectral type O or B blue star. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, spectral type G yellow stars, that's where our Sun fits in. Then there are spectral type K orange stars, and the coolest and least massive stars are spectral type M red stars, often referred to as red dwarfs. Each spectral classification system is also subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 being the coolest, and then a Roman numerals added to represent luminosity. Put them all together, and our Sun is officially classified as a G2V or G25 yellow dwarf star. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were actually born as spectral type M red stars, but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which are between 75 and 80 times the mass of Jupiter, or about 0.08 solar masses. Red supergiants are fascinating objects. After spending billions of years fusing hydrogen into helium in their core, a star's core hydrogen supply eventually runs out, and the balancing act between nuclear fusion pushing outwards and gravity pushing inwards stops, with gravity winning. The entire mass of the star then comes crashing down onto the core. This causes a dramatic increase in the core's pressure and consequently temperature. Things get hot enough to trigger what's called a helium flash. This causes the core helium, which has been created in the star, to begin fusing into carbon and oxygen. At the same time, the hydrogen-rich region around the stellar core has now moved down into that region where the temperatures and pressures are high enough for hydrogen fusion into helium to commence in a shell around the core. Now, as all this is going on, the increasing core temperature results in an increasing level of luminosity, and the resulting radiation pressure from the shell burning causes the outer diffuse gaseous envelope of the star to expand to hundreds of times its previous radius. And as the now bloated star's chromosphere or visible surface moves further away from its core, it cools down, turning redder. Hence the star has become a red giant. Small stars like the Sun eventually lose their outer envelopes completely, which continue expanding outwards as planetary nebula. This ultimately exposes the star's white-hot stellar core as a white dwarf, which is then left to slowly cool down over the eons of time. However, stars with masses more than around 8 times that of the Sun experience a very different fate. Unlike the Sun, their fusion cycle doesn't end with helium in the core fusing into carbon and oxygen. They have enough mass to fuse carbon and oxygen in their core into progressively heavier and heavier elements through a different process, while the shell burning around the core also fuses progressively heavier and heavier elements: carbon, nitrogen, oxygen, neon, magnesium, silicon, sulfur, nickel, and eventually iron. These stars have become supergiants. Eventually they'll explode as core collapse supernovae, ending up as either super-dense strange objects called neutron stars, or even stranger objects called black holes, singularities of infinite density and zero volume, where the laws of physics as science understands them no longer apply. It's too early to tell whether Betelgeuse's ultimate fate will be as a neutron star or black hole. As a red supergiant, Betelgeuse is reaching the end of its life, and it's expected to explode as a core collapse or Type II supernova any day now. Of course, in astronomical terms, any day now could mean tomorrow, or it could mean 1 million years from now. When it does explode, Betelgeuse will temporarily outshine all the other stars in our galaxy, and it will be clearly visible in the daytime sky on Earth. The last star to be seen by humans to go supernova in our galaxy was Tycho's star. That was in 1572, and that was before the invention of the telescope. Diagonally opposite Betelgeuse, marking Orion's left foot, is the blue supergiant star Rigel, the second brightest star in the constellation Orion. Rigel is part of a triple or possibly quadruple star system with 3 or 4 small companion stars. The primary star, Rigel A, is located some 863 light-years away and has about 23 times the mass of the Sun. The star's already exhausted its core hydrogen supply, and it's swollen out to between 79 and 115 times the Sun's radius, and is somewhere between 120,000 and 279,000 times as luminous. Like Betelgeuse, it's now fusing progressively heavier and heavier elements in its core, meaning it too will soon go supernova. Rigel A pulsates quasi-periodically and is classified as an Alpha Cygni variable star. Alpha Cygni variables are variable blue or white supergiant stars which exhibit non-radial pulsations, meaning some areas of the star's surface are contracting while others are expanding. This causes irregular variations in brightness due to beating of multiple pulsation periods. The pulsations are likely caused by iron opacity variations and typically have periods ranging from several days to a few weeks. Rigel A's companion star, Rigel B, is some 500 times fainter than the supergiant, and it's only visible with a telescope. Rigel B itself is a spectroscopic binary system comprising 2 main sequence blue-white stars. Main sequence stars are those happily fusing hydrogen into helium in their core. And spectroscopic binaries are double star systems orbiting each other so closely and at such an angle that they can only be visually separated, at least from our viewpoint on Earth, by their spectroscopic signatures. The 2 stars making up Rigel B are estimated to be 3.9 and 2.9 times the mass of the Sun, respectively. And one of those stars, Rigel BB, itself may be a binary. It appears to have a very close visual companion, Rigel C, of almost identical appearance. The third brightest star in Orion is Bellatrix, Orion's left shoulder. It's a spectral type B main sequence blue star with about 8.6 times the mass and 6 times the radius of the Sun. Bellatrix is located about 250 light-years away. It has an estimated age of approximately 25 million years. Now that's old enough for a star of this mass to have consumed much of the hydrogen in its core and begin the process of evolving away off the main sequence into a blue giant. One of the most stunning nebula in Orion is the spectacular Horsehead Nebula, Barnard 33. The Horsehead is a dark nebula located just south of the star Alnitak, which is the furthest east on Orion's belt, and is part of the much larger Orion Molecular Cloud Complex. Located around 1500 light-years away, the Horsehead Nebula was first recorded in 1888. It's one of the most identifiable nebulae simply because of the shape of its swirling clouds of dark dust and gas, which really does bear an incredible resemblance to a horse's head. To the west of Orion's belt, you'll see a V-shaped grouping of stars which represent the head of Taurus the bull, who in Greek mythology was changed by the god Zeus to carry Princess Europa off to Crete. The V is also part of a large open star cluster known as the Pleiades. One of Taurus's eyes is the giant orange star called Aldebaran, or the Follower, which is located around 65 light-years away and has about 1.5 times the mass of the Sun. Aldebaran is thought to contain a number of Jupiter-sized planets. Aldebaran's already evolved off the main sequence, having exhausted its core hydrogen fuel supply. It follows the Pleiades, or Seven Sisters, a spectacular open star cluster to the northwest of the V. Located in the constellation Taurus, the Pleiades is one of the nearest and youngest open star clusters to Earth, located just 443 light-years away. There's a story in Greek mythology which tells us that Orion fell in love with the Seven Sisters and pursued them for a long time. Eventually, Zeus turned both Orion and the Pleiades into stars. Interestingly, a similar story is told in the Aboriginal Dreamtime culture of the Great Victoria Desert region near Aldeer in outback South Australia. Orion's described as a young male hunter who chases but never catches the Pleiades, who are a group of 7 young women. In Orion's right hand is a club filled with magic fire and represented by the red giant star Betelgeuse. However, the Pleiades' older sister, represented by the Hades star cluster, taunts Orion, standing in front of him. She defensively lifts her foot, which is the star Aldebaran, and is also full of fire magic. And this causes Orion great humiliation, putting out his fire and allowing the Seven Sisters to escape. Now, one of the interesting facts about this ancient Dreamtime story is that it accurately describes the variability of Betelgeuse, which brightens and fades over a 400-day period. The Pleiades' Seven Sisters story is remarkably similar to legends found in many other cultures around the world, and which haven't had any contact with each other for tens of thousands of years. The Pleiades' 7 brightest stars can be seen with the unaided eye, hence the Seven Sisters nickname. But this spectacular open star cluster actually consists of more than 100 stars. Now, if you follow Orion's belt to the east, it brings you to Sirius, one of the nearest and brightest stars in the sky. Located just 8.7 light-years away, Sirius is a binary star system with a spectral type A white star orbited by a white dwarf. It's the brightest star in the constellation Canis Major, the Great Dog. In Greek mythology, Sirius was the dog star and the canine companion of Orion the Hunter. To the ancient Egyptians, Sirius was known as the god Anubis, lord of the underworld, who had the head of a dog and who invented embalming, the funeral rites, and who guided one through the underworld to judgment, where he attended the scales during the weighing of the heart to determine one's fate in the afterlife. Later, Anubis was replaced by Osiris as lord of the underworld. Sirius also represented the god Isis, and ancient Egyptians initially based their calendar on the star's yearly motion across the sky. Now, if you look high in the southern sky in February, you'll see the star Canopus, a white supergiant located 313 light-years away, the second brightest star in the night sky after Sirius. In Greek mythology, Canopus was the helmsman of the Greek king Menelaus, and the brightest star in the constellation Carina, which represents the keel of the boat used by Jason and the Argonauts in their quest for the Golden Fleece. Located nearby are the vessel's sails, represented by the constellation Vela, and the roof of the boat's rear cabin or poop deck, which is represented by the constellation Puppis. Also in the southern skies this time of year, you'll see the large and small Magellanic Clouds, which are 2 dwarf galaxies orbiting our own galaxy, the Milky Way. The Magellanic Clouds were known to the Polynesians and Maori, and served as important navigation markers. They're named in honour of the Portuguese navigator Ferdinand Magellan, who was the first European to sight them during the first circumnavigation of the Earth between 1519 and 1522. Magellan himself didn't complete the circumnavigation. He was killed in the Philippines during the Battle of Mactan. Right now, the Large Magellanic Cloud is located almost directly overhead and is about 163,000 light-years away. Although it looks like an irregular dwarf galaxy, astronomers have classified it as a disrupted barred spiral. It's around 14,000 light years in diameter and contains about 10 billion times the mass of the Sun. Located slightly lower and to the west, you'll see the Small Magellanic Cloud, which is located around 200,000 light years away. It's classified as an irregular dwarf galaxy, about 7,000 light years wide, with about 7 billion times the mass of the Sun. Astronomers speculate that it too was once a barred spiral galaxy, but had become disrupted by the gravitational tidal perturbations of the Milky Way. And joining us now for the rest of our tour of the February night skies is science writer Jonathan Nally from Sky and Telescope magazine.
G'day, Stuart. Well, February evenings, if you have nice dark skies, you can see the Milky Way stretching right across the sky from the south to the north. The Milky Way, of course, is our galaxy seen from the inside. It gets the name Milky because each star is sort of too faint and too indistinct on its own to pick out with the human eye, but you put them all together and it's this big sort of milky, hazy, wispy patch throughout the whole sky. So it's our galaxy seen from the inside. Honestly, if you get to some dark skies, which unfortunately most people these days don't, because we all grow up in cities and things and you've got terrible light pollution and you never see the Milky Way. But if you do get out in the countryside and you can see the Milky Way, then you see our galaxy from the inside and you see what anyone would have seen every night 70, 80, 100 years ago when we had cities that didn't have lights blaring out all the time everywhere and all this light pollution and stuff. It's terrible. You just can't see a thing these days.
And now when you have blackouts, people ring up emergency services and concerned that there are all these lights in the sky.
Well, I think I mentioned this on the program once before that, when that famous TV series Cosmos came out in the beginning of the 80s, about 1980, I think it was. Carl Sagan.
It's the Carl Sagan version, yeah.
Yeah. I remember reading that they got letters from people around the world saying what a great show it was, but they got letters from people like kids who live in places like Tokyo, that sort of cities where there's so much light pollution.
34 million people, Tokyo.
Well, they literally, these letters said, oh, wow, we didn't realise that stars are real. We thought stars were made up for science fiction because we've never seen stars. Yeah, that's how bad it was back then. It's even worse now because there are so many more people living in cities. Anyway, we're getting a bit depressed here. Let's get back to the Milky Way. So down in the south, we've got the Southern Cross, which everyone likes to see. It's the smallest constellation in the sky. It looks a bit like a kite, and at the moment it's flying on its left-hand side and sort of pointing slightly downwards. High above the Southern Cross, you've got a constellation called Carina. Now, assuming you do have dark skies and you've let your eyes adapt to the darkness, you've got to give a good 20, 30 minutes away from any sources of light, then you should be able to make out a wispy patch of light in Carina. It's about the size of a couple of full moons. Now, this is the Carina Nebula, and it's considered to be one of the best nebulas in the entire sky. It's just really spectacular if you look at it through a telescope. To the unaided eye, it's just a faint, diffuse glow, but if you try using averted vision, that's where you don't look directly at something, you look out of the sort of side of your eye, or the corner of your eye, you will get a bit of a better view of it, because looking out the side of your eye ensures that you're using the part of your retina that's most sensitive to the low light levels you get at night time. So try averted vision when you're out in the night sky looking at things. You sometimes do get a bit of a better view. Now, Carina is one of the three constellations that used to belong to one much bigger constellation called Argo Navis, or the ship of the Argonauts. Carina is the keel of the ship. There's another constellation called Vela, which is the sails, another constellation called Puppis, which is the deck or poop deck. Now, Vela and Puppis are also visible at this time of the year. They're up even higher in the sky. They're up above Carina and the Southern Cross. And each of those constellations have lots of great things to see if you have a small telescope or even a pair of binoculars. I started when I was a teenager just looking through a tiny pair of binoculars around this part of the sky, and it's amazing what you can see. The stars look good to the naked eye, but you look through even a small pair of binoculars and you really see them sparkle and shine. It really does make them seem brighter. I quite often prefer to stargaze through binoculars. I've got a pair of 8x56, which are pretty good size. You go higher than that, they're hard to hold because they're a bit heavy. 7x50s are a good size. Binoculars are great for just stargazing. They really, really are. When you use a telescope, yeah, sure, you can see galaxies and things, but you get a very narrow field of view typically, whereas binoculars give you a nice wide field of view, which is great for when you're just sweeping around the night sky for enjoyment purposes, or if you're just beginning to learn your way around the night sky. So if you've got a pair of binoculars, have a look around that area, the constellations Carina, Vela and Puppis, because they're all in the Milky Way and they've got lots of great things to see. Now, higher still than Puppis, and pretty much overhead, in fact, for people who live in the middle southern latitudes, we've got the constellation Canis Major, or the constellation of the large dog. And yes, there is a Canis Minor, the small dog, a little way away. The brightest star in Canis Major, and is actually the brightest star in that night sky overall, is called Sirius. It's actually a binary star system, so we have to say it's not the brightest star in the sky, the brightest star system. But the secondary star is far too faint to be seen. Far too faint. You're really only seeing the one star.
That's a white dwarf, isn't it, the secondary star?
Yeah, it's a tiny little thing, and it's very, very close to the primary star. When you get a binary star system, that's what astronomers call this. They say there's a primary star and a secondary star. The primary star being usually the bigger, brighter one. The secondary star is very often far too faint to be seen or too close to the primary star, so it's lost in the glare of the primary. The brightest star in that other constellation, Canis Minor, the smaller dog, is called Procyon, and it's the 8th brightest star in the night sky. Well, we should say it's the 8th brightest star system because it too is a binary star system. Now, if we keep going along the Milky Way, we get beyond Canis Major, we find the constellations Orion, the Hunter, then Gemini, the Twins, and Taurus, the Bull. Gemini is really easy to spot because it has two bright stars fairly close to each other. They're called Castor and Pollux. Now, Castor is a 6-star system made up of 3 binary star systems all together. There are quite a few 6-star systems out there. The other star, Pollux, it's the oddity. It's just a lone star like our sun. It's so many stars out there are part of binary systems or triple systems or quadruple or whatever.
They make up the most common types of star systems we know of, multiple star systems.
Yeah, there are stacks of multiple star systems up there. A lot of the stars you look up in the night sky and you think, oh, that's a lovely looking star. You may not realise it, but it might be a binary system or a triple or a quadruple or whatever. So that one, Castor, for instance, just looks like one star, but we know it is 6 stars. Pollux, its neighbour, is just a single star. Now, Taurus, I mentioned Taurus. Taurus is easy to spot because it has a very obvious wedge-shaped grouping of stars, a star cluster called the Pleiades. And also, just on the edge of that star cluster is, but not part of the cluster itself, is a bright star called Aldebaran. Let's have a look at the planets. And we have really good planet observing conditions at the moment, really, really good, because 4 of the 5 bright planets can all be seen in the sky at the same time this month. So starting just after sunset, you'll see Saturn about 15 degrees above the western horizon. It just looks like a fairly bright star, might have a sort of a yellowish tint. To Saturn's right, or going sort of north from Saturn, you'll see a much, much brighter star-looking thing. Well, that, in fact, is the planet Venus. It's really bright at the moment. You simply cannot miss it. Now, to the north, there's another bright object, looks like a star, but is in fact a planet. This is Jupiter, and you will find it right next to that star cluster in Taurus, right next to the Pleiades, very close to that star Aldebaran. And Jupiter's going to be brighter than Aldebaran, so you should be able to easily tell them apart. And around to the northeast, finally, there's Mars. And Mars looks like an orange-coloured star, in inverted commas. It's fairly bright at the moment because we've only just gone past the point of closest approach to Earth, which happened mid-January. So when a planet is closest to us, it appears bigger and therefore a bit brighter. So that's why Mars is going to be reasonably bright when we go out and have a look at it this month. For people looking through telescopes, it's a bit of a disappointing apparition, as astronomers call it this time, because while, yes, it was closest in the current years to us in mid-January, closest approach comes around every 26 months. And this one is not a particularly close approach. Now, if the Earth had a perfectly circular orbit around the Sun and Mars had a perfect circular orbit around the Sun, then every time we got to the point of closest approach, it would be the same distance. And Mars would be the same brightness and it would look the same size through a telescope. But because our orbit is not perfectly circular and Mars' orbit isn't perfectly circular, sometimes the point of closest approach, Mars is closer to us and sometimes it's further away. And unfortunately, this is one of the further away ones. And even through a telescope, it looks quite small and you're not going to see a lot of detail on it. So we have to wait for future apparitions at 26-month intervals to get a better view of the red planet. And that, Stuart, is the sky for February.
That's science writer Jonathan Nally from Sky and Telescope magazine. This is Space Time. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.